Good morning, children. Most of you had sent the answers for the questions that I had given as homework on Tuesday after the Zoom class, and some of you had still not sent it. I don't know why, but please make sure those questions are very important. You can expect those kind of questions in the examination. Okay. Now, many of you had the first question was wrong for many of you. It was given density of gas B is 25 times density of gas A. That's what was given, no? There are two gases A and B, and then density of gas B is 25 times that of gas A. Okay, how will the speed of gas B vary from gas A? Okay, so we know that speed of sound is inversely proportional to, okay, when you write speed of sound of B, here it should be of B. Some of you had written B here and had written A here. That's why your answer went wrong. Okay, if you're writing speed of sound in gas B, here density of gas B. Then the other one, speed of sound in gas A will be 1 by square root of density of gas A. Now, density of gas B is 25 times. So, in case of density of B, I write 25 density of A. Okay, and root 25 is 5, root density of A. Is it clear? So, this is speed of sound in gas B. This is speed of sound in gas A. Now, what we have to do? VB by VA or VA by VB is equal to 1 by root rho A upon 1 by 5 root rho A. So, 1 by root rho A into 5 root rho A upon 1. Rho A and rho A will get cut. So, you will be ending up having 5:1. The ratio is 5:1. But the question was, how will the speed of sound of gas B vary from gas A? So, what do we get from this? VA by VB is equal to 5 upon 1, or VA is equal to 5 times of VB. Okay. Or they have asked, how will the speed of gas B vary from gas A? Or VB is equal to VA by 5. So, speed of sound in B will be 1 by 5th of speed of sound in A, or 5 times less. Okay, upon means it is less. Or 1 by 5 of speed of sound in A. This is how your conclusion will be. Okay, children. The second one, almost everybody has done it correct. When you compare between winter day and summer day, you have to see the temperature. Okay, when you compare winter day and summer day, see the temperature, don't see the humidity. The major difference between winter and summer is the temperature. So, high temperature, more the speed, and that reason. Then, if you're comparing rainy day and sunny day, both at same temperature, then you have to see humidity. Is it clear? So, if it is winter and summer, see the temperature. If it is rainy and some other day, then see the humidity. Okay, and then you have to decide. So, I hope you have understood that portion, sound chapter. So, definitely based on that factors affecting, 1 or 2 questions come from that. Okay, so I hope you have understood that clearly. Now, we'll go back to chapter number 1, A part. The exercise of this we had not done. Okay, so I thought we'll quickly do the exercise. So first is differentiate between fundamental and derived units. Then you have system of units. There are 3 systems: CGS, FPS, MKS. These are the old ones, and they are not being used anymore. Okay, because this one is French system, one is British. Now each place had a different system that was causing a lot of confusion. So they created one system called SI system, System International. Now according to that, there are 7 fundamental quantities plus 2 complementary fundamental units. So you have to remember all these 7 quantities plus 2 quantities along with their units and symbols. Okay. Then you had prefix for big measurements, prefix for small measurements. I had told you which all to study, so I'm not going to go into it again. So all the tables, okay, all those conclusions, mainly the tables you have to remember. Okay, centimeter, meter, micrometer, nanometer, Angstrom 10 power minus 10, Fermi 10 power minus 15, kilometer. The bigger units, these are smaller units, bigger units 10 power 3 kilometer. Now astronomical unit, I told you to take it as 1.5. Instead of 1.496, you take 1.5 into 10 power 11. Light year, instead of 9.46, take 9.5. So that it will make your calculation easier. So light year alone, I want you to pay attention. A light year is the distance traveled by light in 1 year. Distance traveled by light in 1 year. So how do they get that value is 1 light year is speed of light into 1 year. Time. Speed into time. Okay. Distance is speed into time and time is 1 year. Now 1 year you have to write in seconds. So 365 into 365 days into 24 hours. Every hour has 60 minutes. Every minute has 60 seconds. Okay. So you don't have to do this multiplication, but I just want you to know this. Light year is the distance traveled by light in 1 year. Okay. Then coming to mass, again gram, milligram. I'm sorry children, I had told you to cut this. Please have this. You have to write this. Atomic mass unit. This is the unit of atomic particles like proton, neutron and electron. They are measured using a unit called AMU. Okay, and its value is 1.66 into 10 power minus 27 kg. Okay, so this is important. Then so in this you don't have to memorize, you can multiply and write. You just have to remember this, that decade means 10 years. So you know 1 year will be in how many seconds, so multiply it with 10. Century 100 years, millennium 1000 years. Okay, so this also you know how to calculate. You remember only this, 1 day has 86,400 seconds. 1 day has 86,400 seconds. So 1 year will have 365 into 86,400. That will be this much. Decade, that into 10. Century, that in this into 100. Millennium, this into 1000. So that's how. Don't try to memorize everything. That will be confusing. You know these three. From that you can calculate these by yourself. Okay. Now there is one more thing called derived units. In the beginning itself I told you there are basically 2 types of units. Fundamental units and derived units. Now fundamental units means the units that are not derived from anything. In the sense, mass is a fundamental quantity and its unit is kg. I didn't derive this kg from anything. Okay. Length is a fundamental quantity and its unit, SI unit is meter. Okay. These are fundamental quantities. Now derived quantities means, or derived units means, these are the units are derived from fundamental units. These are the units that are derived from fundamental units. Let's see, for example, let's see velocity. Okay, velocities formula is speed is equal to distance upon time. Distance upon time. Now velocity is not a fundamental quantity. You don't have it in the table of fundamental quantities. Okay, so it is a derived unit. How do you derive its unit? Go to the basic formula. Now distance and time are fundamental units, and distance unit is meter, SI unit is meter, time is second. So velocity's unit is meter per second. Is it clear, children? So these are called derived units. Now same way, acceleration. We did acceleration in the previous chapter. So acceleration will be change in velocity upon time. Now change in velocity, just now change in velocity means velocity is unit. Just now we derived it as meter per second, time per second. So meter per second into 1 by s, that is meter per second square. Okay, so this is how you get the units for these terms. Okay, these are called derived units. So some examples you are supposed to remember. Derived units. First 5 I want you to remember. Area, length into breadth. Volume, length into breadth into height. They are simple. Density, mass upon volume. Kg per meter cubed. In symbol, it will be kg m minus 3. Okay, speed or velocity, acceleration. Okay, so all these 5 you should be able to know how you get the derived unit. So now, how can you expect questions from A part? Now, one thing is they can ask like this. Complete the following. 1 light year is how many meter? Like this. So you should know the relationship. Then you will write all this. Okay. So I want you to do this. 15, 18 and 24. Okay. Its answers are given. If you can write without seeing, that will be great. 15, 18 and 24. Please write it in your notebooks. Now, apart from that, these are given as numericals, but they are not numericals. Basically, they are asking you to convert from one form to another. Okay, so we'll do some questions. First question: the wavelength of light of a particular color is 5800 angstrom. Express it in nanometer and meter. Okay, so wavelength of light, wavelength is lambda, is 5800 angstrom. Okay, 5800 angstrom. Angstrom means A with a small circle at the top. Okay, now you are asked to express it in nanometer and meter. Okay, you have to express it in nanometer. Symbol is nm, B is meter. Now you do meter first because meter is directly, you know, the relationship. Then we'll go to nanometer. Now, what is the relationship between meter and angstrom? So 1 angstrom is 10 power minus 10 meter. Now these all you have to remember, children. Okay, 1 angstrom is 10 power minus 10 meter. Or, so 5800 angstrom will be 5800 into 10 power minus 10 meter. Okay, now because there are 2 zeros here, I can take it as 10 power 2 positive because there are 2 zeros, and already I have 10 power minus 10. So what will happen? Multiplication, powers get added. So into 10 power 2 minus 10, you get minus 8. So the answer will be, in meter it is 58 into 10 power minus 8 meter. In book it is given 5.8, so it will be 10 power minus 9. Sorry, 10 power minus 7. Okay, so we have found in meter first, B part first, then we go to nanometer. Now once you find in meter, you know the relationship between meter and nanometer. 1 nanometer is, nano is 10 power minus 9 meter. So we have to write the reverse. 10 power minus 9 meter is 1 nanometer. If that is the case, 58 into 10 power 8 minus 8 meter will be 1 by 10 power minus 9 into unitary method. This upon this into this. 58 into 10 power minus 8. So 58 into 10 power minus 8 plus 9. This, if it goes to the numerator, it will become plus 9. So 58 into 10 power 1 or 580 nanometer. So in nanometer it is 580, in meter it is 58 into 10 power minus 8 meter. So this is how you have to do the conversion. Okay, so questions can come like this. They'll give it in one form and they can ask you in some other form. Okay, so I'll do the second question now. I hope you're noting down along with this. So after these three answers, I expect you to complete all these numericals. I will be doing most of them, and 2-3 are homework. You will be doing that, so do it with me. Second one, size of a bacteria is 1 micron. Okay, this is micron, a micrometer. Find the number of bacteria in 1 meter length. Okay, so they are saying one bacteria size is 1 micrometer. You write it as micrometer, that's better. Okay, size of one bacteria is 1 micrometer. That is very, very small. If that is so, in 1 meter, how many bacteria will be there? In 1 meter, so length should come to the left hand side. So in 1 micrometer, there is only 1 bacteria. So in 1 meter, how many bacteria will be there? That's the question. In 1 micrometer, 1 bacteria is there. So in 1 meter, how many bacteria will be there? Now, one thing, I have to have both of them in the same unit. If this is in meter, this also has to be in meter. Now, 1 micrometer, if you remember, micro means 10 power minus 6. So 10 power minus 6 meter is equal to 1 bacteria. If that is the case, 1 meter will be 1 upon 10 power minus 6. Okay, this upon this into 1. So 10 power 6 bacteria. Okay, in 1 meter there will be 10 power 6. 10 power 6 means 1, 2, 3, 4, 5, 6. 10 lakh bacteria will be there. You can just leave it here. That's enough. Okay, children. So this is basically conversion from one unit to another. Now third one, you can do it as homework. Distance of galaxy from Earth is this much. They have given distance and then speed, and they've asked you to find time. You know that speed is distance upon time. So time is distance upon speed. So do the division first and then you will get the answer. Same way, fourth one, wavelength they have given in nanometer and they've asked you in angstrom. Just the opposite of this. Here they gave you in angstrom, asked you in nanometer. Here they are giving in nanometer and asking you in angstrom. Okay, so what you do, you first convert nanometer to meter, then meter to angstrom. That is easy. Okay, then fifth one, the mass of an oxygen atom is 16 U. U is AMU, atomic mass unit. I just now told you to remember that because it keeps coming sometimes. So, mass of oxygen, fifth one, mass of an oxygen atom is 16 U, okay, or 16 AMU. Now, 1 AMU is equal to, 1.66 into 10 power minus 27 kg. Remember? Yeah, 10 power minus 27 kg. So, 16 AMU will be 16 into 1.66 into 10 power minus 27. You just have to multiply and you will get this answer. 2.656. I have checked in the calculator. So, you can, don't worry. 2.656 into 10 power minus, you will get it as, when you multiply this, you will get 26.56 into 10 power minus 27 kg. Now in the book, they have written 2.656. Okay, they have shifted the decimal by 1 digit here. So this, they have subtracted 1 from this. Hence it will become minus 26. Is it clear, children? So, sixth one is again homework. It takes 8 minutes for light to reach from the sun to the earth. Okay, speed of light is taken as this distance. So here the same formula, distance is speed into time. So you have the speed, you have the time. Remember, this has to be converted to seconds. Because this is in second, this has to be converted to seconds. That is 8 into 60. Then you do it, you will get this answer. There's no conversion and all, you just have to. Okay, they have converted. Okay, they've asked in kilometer. You will get the answer in meter, converted to kilometer. That's easy. 7th one. The distance of a star from Earth is 8.33 light minutes. Okay. So, what do you mean by this statement? Express it in meter. Okay. 1 light year means distance traveled by light in 1 year. Light minute means distance traveled by light in 1 minute. Okay. So, 7th, distance is equal to 8.33 light year. Sorry, light minute. Okay. So, distance traveled in same way, speed is equal to distance upon time. Okay, so speed is equal, distance is equal to speed into time. Okay, so speed is, now time will become 8 into okay, so we have to find the distance, speed into time. Speed of light 3 into 10 power 8 meter per second into 8.33 minutes. So in seconds, if I have to convert it into second, 8.33 into 60. 1 minute is 60 seconds. So if I multiply this, I will get 3 into 10 power 8 okay, this is light minute. So 8.33 light minute will be, if I multiply this, I will get 1.5 into 10 power 11 meter. Is it clear, children? So 1.5 into 10 power light 11 meter. Okay, so if they would have asked, if they would have said light year, so you have to write time, you have to take 1 year, and in 1 year how many seconds? 86,400 seconds. So you will have 86 instead of 60, you will have 86,400. Because it is light minute, I have 60. If it was light year, here it will be 86,400. Remember that. Okay, so for Tuesday's test, you're going to prepare first chapter. So as usual, as I told you, A part and C part. Or children, you leave this chapter. Okay, this has lots of numbers, lots of numericals, and generally we all make mistake. Okay, so why not you study sound chapter fully. Sound chapter, I remember you gave a test earlier, but that was not a proper test. So please study sound chapter. That is much better because you have lot of theory. You can score some marks. First chapter, I know what will happen. Okay, so you all know what to study. So earlier I had cut this. Now you'll have this. Mainly the questions that I gave you for practice, you do that. That's enough. And then simple numericals, and then ultrasonic and infrasonic. So on Tuesday you will have test of chapter 8 during Zoom class, that is 9 to 10. So please prepare thoroughly these 3 days and do your test well. Because it's going to be a 1 hour test, you will have at least for 25 marks. 20 to 25 marks test will be there. Okay, so be prepared. Thank you, children.